Welcome. Today, we're diving into a game-changing approach for agent-user interactions, integrating the Microsoft Agent Framework with AGUI. As intelligent agents become more common in our digital world, the need for seamless, standardized communication between agents and users is more critical than ever. In this video, we'll walk through why this integration matters, how it fits into the broader agentic ecosystem, and what steps you need to take to get started. Whether you're a back-end developer or just curious about the future of AI-driven applications, this guide will help you understand the power and simplicity of AGUI. Let's get started by exploring the evolution of agent protocols. Over the past few years, we've seen major strides in standardizing how agents operate. First, the Model Context Protocol, or MCP, gave agents a common way to integrate tools. Then, the Agent-to-Agent Protocol, or A2A, enabled smooth communication between agents themselves. However, one critical piece was still missing: a standardized way for agents to interact directly with users through the user interface. This is where AGUI steps in, bridging the gap and enabling a new level of interaction. In the next scene, we'll introduce AGUI and explain why it's a breakthrough for developers and users alike. AGUI, or Agent User Interaction Protocol, is an open, lightweight, event-based protocol designed to standardize how AI agents connect to user-facing applications. It provides a consistent and flexible way to handle interactions between the agent backend and the front-end user interface. This eliminates the need for every developer to build a custom UI layer from scratch. AGUI ensures that agents can communicate with any compatible front-end, making the development process faster and more reliable. Next, let's see how AGUI fits into the overall agentic stack. Modern AI agents share several core features. They handle long-running queries, support tool calling, manage multi-turn conversations, maintain memory, and stream tokens. Previously, developers had to reinvent the wheel to make these features work in the front end. AGUI changes that by offering a standardized, event-driven approach for real-time, bidirectional communication between your agent and the app. This works regardless of the underlying transport method, whether it's SSE, WebSockets, or webhooks. AGUI bridges the final gap between intelligent agents and intuitive user experiences. AGUI fits seamlessly into the agentic stack, following a client-server architecture designed for interoperability. MCP connects agents to external tools. A2A enables agents to communicate and collaborate. And AGUI bridges the final gap by connecting agents to user interfaces. This means that any AGUI-compatible client or UI application can connect to your agent, consuming and visualizing responses in real time. The result is effortless communication between back-end and front-end, without custom wiring or tight coupling. Let's walk through the server-side implementation. Imagine you're building a study assistant agent that helps students plan their study schedules. The first step is to create a starter ASP.NET Core app and add the necessary NuGet package references. These packages include Azure, AI, OpenAI, Azure, Identity, Microsoft, Agents, AI, Hosting, AGUI, ASP.NET-C, and Microsoft, Agents, AI, OpenAI. With these in place, you're ready to define your AI agent and expose it via AGUI. In your .NET project, start by adding the required NuGet packages. These include Azure, AI, OpenAI for AI capabilities, Azure, Identity for authentication, Microsoft, Agents, AI, Hosting, AGUI, ASP.NET-C for AGUI hosting, and Microsoft, Agents, AI, OpenAI for agent integration. These packages lay the foundation for building and hosting your intelligent agent within the Microsoft Agent Framework. Once installed, you're ready to define your agent's capabilities. Next, define your AI agent in program.cs using the Microsoft Agent Framework. For example, you can create a chat completion agent and add a tool function, such as Get Academic Calendar, which fetches the academic calendar for a specified semester. You then define your agent with a name, instructions, and the tools it can use. This modular approach makes it easy to expand your agent's capabilities as needed. With your agent defined, the next step is to expose it via the AGUI server. This is remarkably simple, just one line of code using map AGUI. There's no need for controller, logic, or threading code. Instantly, your agent is ready to be consumed by any AGUI-compatible front-end. This simplicity is one of the key advantages of the AGUI protocol. Now, let's shift to the client side. To create a user-facing application, you can start with the Quick Start template from the official AGUI repository. AGUI supports two types of agent tools: front-end tools, which execute directly in the browser, and back-end tools, which run on the server. This abstraction allows back-end engineers to focus on logic, while front-end tools are automatically wired into user messages. The result is a powerful, flexible user experience. To get started on the front end, install CopilotKit using the command npx CopilotKit at latest create. This tool streamlines the process of setting up your AGUI-compatible client application. With CopilotKit, you can quickly scaffold a project that connects to your agent and handles real-time interactions. Once installed, you're ready to configure your app to communicate with the agent server. Update your apps.route.ts file to point to your server endpoint. This involves creating a Copilot runtime instance and specifying your agent's URL. The Copilot runtime handles communication between the front end and back end, ensuring that user messages and agent responses flow smoothly. With this setup, your client is ready to send and receive data in real time. With everything configured, simply run npm run dev to start your application. Your agent is now live and functional, ready to interact with users through the AGUI protocol. This rapid setup process demonstrates the efficiency and power of standardized agent-user integration. Now, let's look at how you can enhance the user experience even further. To improve user experience, AGUI allows you to visualize when tool calls are made and completed. By using the Use Render Tool Call hook, you can dynamically render back-end tool calls directly in your front end. This feedback helps users understand the status of their requests, making interactions more transparent and engaging. It's a simple addition that greatly enhances usability. With the Microsoft Agent Framework and AGUI, developers now have a simple, standardized way to bring intelligent agents into real-time, interactive applications. This integration is fast, flexible, and framework-agnostic, making it the missing UI link in the Agentic ecosystem. By following these steps, you can create powerful, user-friendly AI experiences with minimal effort. Thanks for joining us on this journey through agent-user integration.